the system grabs one image of the head from a side. The screw dimensions are then determined from the grabbed image using mathematical tools. A clear and large image can increase the inspection accuracy. These are the measuring points for the height and the width of the head, and the height and the width of the washer. The system grabs one image of the screw from a side. The screw dimensions are then determined from the grabbed image using mathematical tools. The thread angle is defined as the angle between the line connecting a pair of thread peaks and a horizontal line. These are the outer and inner diameters of the screw, the thread pitch, and the thread angle. The cone points are inspected by comparing the incoming screws with a sample previously taught to the program. The passing level is determined by a required level of similarity. The evaluation of similarity is based on the theory of pattern matching, without further assistance from the camera. There are two ways to measure the length of a screw, either excluding or including the head. The measuring points of the length are always shown in two separate images on the computer screen. To avoid measurement errors, the center of the camera lens should be placed at the same level as the screw bottom. An image of the inspected screw is grabbed from a side. The body diameter is measured using the neck width option in Engineer, Parameter, Specification Feature Setup of the software. The following shows the lengths without the head and the body diameter of the screw. To verify if there is any thread inside the hole on the head, the press head uses an appropriate bit. When there are threads, the bit cannot go fully into the hole. On the contrary, if the bit goes into the hole completely, then there is no thread inside, and the screw is rejected by the system. The press head uses an appropriate bit to simulate how the recess is checked manually with a depth gauge. The recess is acceptable if the bit can go completely into the hole. Otherwise, the screw is rejected. To inspect the height and shape of the screw head, use the press head with an appropriate socket. combining the measurements of the height and shape of the head. The program can screen out screws with distorted heads, missing friction rings, or distorted cover positions. This feature of the program screens out screws with problems like half thread, bevel thread, and no thread. The image of the screw thread is grabbed by the program and compared with a sample previously taught to the program. The passing level is determined by a required level of similarity. The evaluation of similarity is based on the theory of pattern matching, without further assistance from the camera. Screws with problems of a hall point, a bent body, or a point cut cannot be correctly identified from a single image angle. Our CCD machine has the capacity of grabbing multiple images of a screw from different angles. The press-down mechanism rotates the inspected screw by 180 degrees. Meanwhile, the system grabs still images of the screw from up to 6 different angles. Each inspected screw is lifted up from its bottom, so that the area under the head is exposed to the camera. The system checks if the outer diameter of the first thread meets the requirement, and if there is any jump thread under the head. The CCD3 grabs the image of the head from above. Aerial measurements are determined from the grabbed image using mathematical tools. Then they are compared with the reference data set in the program. When the difference between the two values is larger than the set tolerance, the screw is identified as one with a head crack and is rejected by the program. Use this feature to check if there is any mark on the head, or to separate screws with different kinds of marks. The system compares the grabbed images with the sample taught to the program and screens out the screws below the acceptable level of similarity. The center of the incoming screw image is calculated by mathematical means. Then it is compared with the calculated center of the sample screw taught to the program. The distance between the two calculated centers is called eccentricity. If eccentricity is larger than a preset level, the screw is discharged as defective. The system uses the calculated center along with the circumference of the incoming screw to determine 12 equally spaced diameters. The difference between the largest and smallest diameter is compared with that of the sample screw taught to the software. If the difference is larger than the preset tolerance, the screw is discharged as defective. The system can also check the welding points on the head, the welding points under the head. and the convex ring under the head.